Okay, we'll go with Vax, Wax, Waxy, Vaxy.
What's up, Jaron? How you doing?
Good, you?
I'm good. Everything, like the conversation, me listening to you was going good till about 2 seconds ago when you said that saying that it's not a science experiment is something that just certain flat earthers say.
It is.
If it's a science experiment, what's the independent and dependent variable? You don't have one.
Why not?
Well, what is it?
The location that we saw the observation.
The location that you saw so you're going to vary and manipulate your location for an observation?
Correct. Because in certain places on the Earth, you wouldn't expect to see a 24-hour sun. In other places, you would. So we varied and manipulated our position. You couldn't see a 24-hour sun from where you were, but where we were, we varied and manipulated our position and saw a 24-hour sun.
It's literally not. No, you varying and manipulating where you are is not. That's not an independent variable.
Why not?
Because you're just changing your distance, like your location to something.
So when you have another independent variable, you're just changing one part of the experiment also. So you get to pick and choose what we can change and what we can't.
Right, but it's literally not. That's not the criteria of an independent variable.
So independent
just say,
variables.
I'm going to go. If I stand here versus me standing over there, that's. Anyway, I didn't even want to get hung up on that.
Neither do I, because it's a dumb argument. Because really, what is an experiment? Is we're meant to go make an observation, make a hypothesis, and see if our prediction comes true in reality. That's all it really comes down to. Your
prediction would be a hypothesis.
Right. So the hypothesis is whether or not there should be a setting sun in Antarctica. So why would that not be something that we would call science?
Because it's literally not science.
Making an observation after a hypothesis that one would lead to.
For one, you guys were going down there to see if there was even a naturally observed phenomenon to be taking place. And for what, it's not just an observation; it has to be a naturally observed phenomenon. And you changing your location while looking at the sky is not an independent variable. But again, that's not even the points I wanted to get on. The point I wanted to get on was you did say something earlier that I 100% agree with.
Okay.
You said that the Earth is measured flat.
Yep.
And I find it funny why you're so quick to just like run away from that 100% proof that Earth is not an oblate spheroid.
Because we cannot explain what the sun does.
What does the sun have to do with the Earth being measured flat? That's the whole point. Okay. That's the whole point of why the sect that I'm in, all the flat earthers that I know, have not given a toss about the quote-unquote final experiment, or as Will Duffy said, the final expedition.
Okay, so imagine, let me just bring up something real quick. Imagine that we had some observation of the sun that matched the flat Earth, and we start bringing it up to globe earthers, and they just say, it doesn't matter what the sun does. You wouldn't accept that. You would laugh in their face. You ask them all the time how far the sun is, things about the sun, the seasons. Now, when it's on, you guys don't even understand that you're being one-sided. You can either take it both ways or don't. If we're not going to allow to mention the sun, then we can't mention it for seasons. We can't mention it for anything. Because you'll choose to say it sometimes.
Me personally, I don't use seasons or anything for
nothing.
An argument for flat Earth. That's some
you don't
weird
use the sun at all.
Hocus Dave Weiss talking points.
Okay.
They're not good arguments.
That might be true. Okay. I would agree with you.
Yeah, but the thing is, Earth's physically measured flat.
It measures flat, and yes.
Yes. And the thing is, what's a glober going to say? They're going to scream tangent. Once a glober screams tangent, what are they doing? They're apologizing for how not curved their angle measurement is, because you cannot have a elevation angle with a curved baseline.
You watch too much Nathan Oakley. You watch too much Nathan Oakley. Show me this. Hold on. This pen.
That's a non-response.
Hold on. This pen right here. No, it's not.
That's literally a non-response.
Well, I'm trying to respond to you right now. Say this pen right here. If somebody sat on top of this, could they get an angle measurement to a light on my ceiling?
They would have to use a bubble sextant. Wouldn't they? Not a Mariner sextant.
Okay, but would they be able to, from the curved top of this pen, would they be able to look up, if a little being lived here, would they be able to get an angle measurement to anywhere on the ceiling in this room?
Sure, as long as that.
But there's a curved baseline, but they got a curved baseline.
As long as they're able to establish a horizontal off the surface of that pen.
That's what the Globe Earth claims to do. They make
Globe Earth claims that they have horizontal planes on a sphere.
Correct, they have a tangent.
How many horizontal planes does a sphere have?
Unlimited.
Yeah, isn't that the problem? The thing is, Jared,
No, it's not a problem. It's not a problem.
You're in California, right? It's not, because we're both in North America.
Okay.
I'm in the Southeast. It's both nighttime for us, right?
It's nighttime for me, yes.
Okay, I just wanted to make sure you're home or what. Not that matters. Right, gotcha. I don't care where you live, nothing like that. But I've heard you say before that you live in California. Or at least that's what I assumed. Anyway.
Yes.
If me and you were to both go outside right now.
Right.
And take an elevation angle to Arcturus or the middle star in Orion's belt.
Can we do that? That's not an experiment.
I'm not saying this is an experiment. This has nothing to do with science.
Oh, okay.
Yeah, this is all just math. It's geometry.
Okay.
Right. To call this an experiment would be a category error.
Okay. So what are we doing?
Well, what I'm saying is, let's say that I go outside and I look at star A, and then you look at star A. For me, star A is at 45 degrees in the sky.
Mm-hmm.
For you, let's say star A is at 36 degrees. Yeah, whatever.
Whatever.
Our angles, the baselines would smash into each other. They're on the same horizontal plane. I feel like this is what you guys aren't getting. If I was to go outside and make a circle of elevation at Polaris, let's say Polaris for me is 32 degrees.
Correct.
Somebody in London makes a circle of elevation around Polaris at 51 degrees.
Okay.
Our circles of equal altitude are on the exact same horizontal. You cannot have that on a sphere. It's physically impossible. That's not how a sphere operates. And for one, spheres don't have horizontal planes anyway.
Right, but do they have circles?
Anytime you take an elevation angle, that elevation angle has something called a ground position,
right,
or a geographical position, the GP of the star.
Correct.
At some point, that star is going to be at 90 degrees.
But hold on.
Now, that star's
the equal elevation.
Well, that's what the GP would be, 90 degrees. That means that wherever that star is, that's the zenith of the star.
Correct.
In the location that it's at, it's going to have a ground position. Right. That ground position is perfectly parallel and on the same horizontal plane as as where I'm standing.
Okay, but not if you're on a circle. If you're on a circle around that spot, then everybody in that circle has the same angle to the star.
Yeah, but a circle is not a three-dimensional sphere. A circle is a flat surface.
Correct. On a sphere.
Right. Yeah, exactly. Correct. No, not a sphere. What? No. If it was a sphere, how would my angle to Polaris be on the same horizontal as somebody in London or Bangladesh or whatever? It wouldn't
not true.
Be, but it is.
But it's only the same degree as you.
But the thing is, it's all based off the same horizontal. There's only one horizontal you can have for celestial navigation to work. If you have multiple different horizontals, that means these angles are never going to line up with each other.
But that's not what they're doing. They're not lining up with each other. They're just getting the angle to the star. Then you know how far away you are, and then you're on that circle, and you have two of those circles or three of those circles, and you can pinpoint where you're at.
Mm-hmm.
Okay, I don't know why there's a problem with that.
But they're all on the same horizontal.
Okay, all right.
And the thing is, if I'm in a boat and I have my Mariner section, which is really the crux of the argument, because Globers want to kind of like go down an alley and start talking about aviation sextants. But the thing is, if I'm in a boat and I take a 45-degree angle to a star, and then I get in a blimp, go 500 feet above that same position as the dude in the boat, they take that same angle to the star at 45 degrees. Then you get in a jumbo jet with an aviation sextant. They take a 45-degree angle to the same star that I took in the boat. And then you get an SR-71 Blackbird flying above that. They're all on the same horizontal.
Mm-hmm.
Every time, like, you take an elevation angle, it's all going to be perfectly parallel to the person in the surface of the boat.
Right.
And I feel like that's you're saying it right, but at the same time,
how does that explain
understand that.
Well, how does that explain on a flat Earth?
It can only work on a flat Earth. You cannot have an elevation angle with a curved baseline.
So you're going to draw a flat Earth, and then you're going to have all these things on top of each other. They all have the same angle, though, to something in the sky, but they get higher and higher?
Right.
How's that?
How is what?
How does that happen? How could that be the case?
Well, what are we taking angles to?
I don't know. You're the one who brought up the example.
Well, we're taking angles to stars. We could pick one in Orion's belt. We could take an angle to Jupiter. We could take an angle to Polaris.
Okay.
What is Polaris and where is it?
Above the North Pole?
Yeah, but what is it and where is it?
But I just said above the North Pole.
Yeah, but what is Polaris?
A star.
Right. What is that?
I don't know. Light.
There you go. How high is it?
I don't know.
How far away is Polaris?
What difference does that make?
See, that's the whole thing. What difference does it? Doesn't make a difference. The height's never accounted for.
Right.
So you're asking how we're taking angles to things that might not even be a tangible object.
Yeah, I'm not asking that question. I don't think that stars can be determined their distance at all. ever.
Right, exactly. But the thing is, we don't know what they are. We don't know how big a star is. We don't know what a star is made out of.
Right.
The only thing we know about stars or the sun or anything that's in the sky is its apparent location.
Do you have a point, or let's get to the next person? Because I don't know where we're going with this. I don't need to be arguing that fact with you. My point is, I think that that's a dumb argument to say that we can't take angles from a curved baseline, because we're not taking angles from a curved baseline. You're taking angles from a tangent.
Okay, fine, but let's just clear the air. What is an elevation angle?
An angle between you and something in the sky.
That give you a C minus.
Well, I'll take it.
Well, okay, so we'll just go to Merriam-Webster. Let's see. Angle of elevation, noun phrase. The angle formed by the line of sight in the horizontal plane for an object above the horizontal. Right. Spheres do not have horizontal planes.
The tangent. They use the tangent. They don't use the sphere.
Well, okay. So if they want, that's begging the question. They say tangent, how is there any proof that we're on a sphere anyway? And they're going to go say tangent.
I didn't say that was proof of being on a sphere. So you're talking to the wrong guy.
Right, but when they say tangent, that's literally a begging the question fallacy.
It's not when you're just using it for its activity. If you're saying, let's pretend for a second that we lived on a sphere. Just pretend. Would we then look at stars in the sky and be able to take angle measurements to them? The answer is yes. How would we do so?
By using absolutely categorically no.
Why not? We would use a tangent.
What is a 90-degree angle?
Straight up.
And?
What do you mean?
Well, it has a baseline, right?
Sure. It could be a tangent, though.
Yeah, two lines meeting at a right angle.
Again, do I need to show you this pen? If you were on top of this, would you be able to take an angle measurement of 90 degrees? There's no bottom baseline.
Establish a horizontal on the top of a pen.
You could. It's called a tangent.
Well, yeah, but what's a tangent based off of?
The local flatness. The top of my pen is the equivalent of being flat.
Just a local flatness, though.
That's
like Earth's a disco ball.
No, nobody said anything about a disco ball.
Well, the thing is, Jaron, when a Glober claims tangent line,
I see.
When a Glober says tangent line, all they're doing is apologize for how not curved they're measuring the Earth.
Okay, so tell me this:
they have to have a horizontal baseline for their angle.
Okay, so if we have a Home Depot built on the Earth, if we put a level anywhere in that Home Depot, would it be level everywhere?
Say that one more time.
So we build a Home Depot on, let's say, on a sphere Earth, but we put a level everywhere, every aisle of Home Depot. Will every aisle say it's level?
What's level in relation to? Horizontal.
I'm talking about
horizontals on a sphere.
Here we go. That is literally your inability to understand large spheres.
Large spheres?
Yeah, large spheres have flatness everywhere.
No, they do not.
Okay, so you're clueless. I mean, this is the problem.
Karen, they claim it curves at 1.2 times the square root of the observer's height in feet. If you're 1 foot above the surface of water, the geometric curve, which is the edge of the ball, which is the part that's curving away from you, would be no more than 1.22 miles away.
Okay, so again, we're building
They don't have that. They don't have a radius value.
Let's listen again. We go back to a Home Depot. We build a Home Depot on Earth. Let's say it's a sphere. Okay? But we build a Home Depot. Is the ground level and flat of the Home Depot?
This is a really poor analogy.
It's not a poor analogy. It's because you guys don't get this that bothers me. It's like we have to recognize that a sphere could be so big that the ground...
So big it's flatty, right? Yeah, it's so big it's measured flat. That's what you're saying.
Yeah, that's the truth.
Right. So again, if it is a sphere, they're literally begging the question of it being a sphere. There's no proof that it is.
Correct. The Earth measures flat locally and it is stationary, but the sphere describes the sky. That's the truth. You can cry about it, but that's the truth.
What do you mean the sphere describes the sky? The sphere is a horizontal. The sky is horizontal. The only curvature that exists in this world is the apparent curvature when we look at the sky.
The only what?
When things appear to go east to west, they appear to arc. What they do is they take the arc of the sky and they shoehorn it onto the floor and go, "Hey, look, Earth's a ball." That's not true.
Okay, what about the sun going backwards for somebody in the south? The opposite direction. How do we explain that?
The opposite direction. The sun goes east to west around Polaris.
I just went and proved that that's not true.
So the sun wasn't going east to west where you were at?
No, the sun goes right to left.
Right to left is subjective. Right to left will change whether you're facing north or
it's not
south.
subjective when you think about it this way. So at the North Pole, which way does the sun go?
East to west.
No. Does it go left to right or right to left?
It depends on what direction I'm facing.
It doesn't.
It's going right
it doesn't.
to left
So
or left to right.
you get too upset, and you're not just listening to what I'm saying. Listen.
No, it's just.
No, you're wrong. So listen to what I'm saying.
No, you're using a poor Glober argument.
I'm not. It's not a poor Glober argument just because you don't get it.
It literally is.
If you're at the North Pole, think for a second. If you're at the North Pole, which way is the sun going? Right to left or left to right?
It's going east to west.
Son of a
Jaron.
bitch. You can't put yourself at the North Pole on a flat Earth.
So in the North Pole, the sun doesn't go east to west.
I'm asking you, would it go left to right or right to left? If you can't
It
answer
really depends on what direction I'm facing.
Sorry, you're at the North Pole. There's only one direction. It's called south.
So I can't. So if I go to the North Pole, I can't face north.
Correct.
So I'm like at the zenith of Polaris.
Let's say you're at the very North Pole of the flat Earth. Which way does the sun go? Right to left or left to right?
Has anyone been there? Because that's the other thing too. Like people only want to talk about the.
I gotta let you go. I gotta let you go. You guys are intellectually dishonest.
I'm being intellectually dishonest, and you can admit that the sun goes east to west.
I'm asking you. Okay, so I know that it goes east to west, but I also know that that is a certain direction from the North Pole. It can't be right to left. That would be impossible. So it means
I never said right to left. You did.
No, because you won't answer my question. If you're at the North Pole, the sun goes left to right. Every day, every time, every year, no matter what. It can't go right to left. Do you understand that?
So if I'm at the North Pole and I'm facing north, the sun's going right to left. But what if I turn south?
No, if I turn south, I'll never be able to look at the sun? Hold on. The sun never goes right to left. So I didn't say that. If you're at the North Pole, the sun goes left to right. No matter which way you look. No matter which way you look, the sun is moving left to right. That's the orbit that it goes left to right. Right? Think of a flat Earth.
Yeah, my phone's at 1% too. So if I cut out, my phone's literally at 1%.
Think of a flat Earth, though. We know that the sun goes clockwise around it. So if you stand in the middle of that clockwise rotation, then the sun is always going left to right. Okay? There's a problem.
Clockwise is subjective based on if you're facing north or south. If you're facing, if you have 3 cameras set up in your yard, you got one facing north, one facing south, and one in the middle, you'll get clockwise and counterclockwise star rotation.
I mean, for me, it's just bothersome that I'm making a point that you can't even grasp the point. You're just skipping right over it into some nonsense where I'm just making a simple point. If you're standing at the North Pole, it is objective that the sun must go left to right. You can turn any direction you want. The sun goes left to right. So you're getting confused.
If I'm standing at the North Pole and I'm looking south, the sun's going to go
left to right.
Left to right. But then if I face north, the sun's going to go right to left.
There is no facing north. You're at the North Pole. Every direction is south.
So you can't face north at the North Pole is what you're telling me.
Where would north be?
But if I was facing south, wouldn't I have to be looking at my feet?
No, you're looking south away from you at the North Pole.
Right, because you're pretending we're on a ball, Jaron.
I'm not. I'm telling you on the flat Earth. We're talking about the flat Earth right now. The flat Earth has a sun that goes clockwise over the top of the flat Earth. If you're inside that middle, you're at the North Pole, the sun moves left to right all times. It's like not even, I don't know what I'm arguing with you about. If you can't get that, then there's no one, it's not even a surprise to me that you can't get what I'm saying about everything else. Because we're not even able to get past that. It's
you literally don't know what the difference between clockwise, counterclockwise, and east to west is, dude. And you've been at this for how long?
And here's the thing. This is how you guys all act. And you don't even realize that you're the one that's grossly wrong. And it's just pathetic that you're
over here talking about taking elevation angles off a pen. How am I wrong?
Because you're wrong about it. If I take an elevation off a pen, I could do that. If I lived on a pen, I could go to the top and draw a tangent.
How would you take an elevation angle off a pen, Jaron?
Like I just told you, you draw a tangent. And you find the item in the sky and use whatever you want to use, the astrolabe, and figure it out.
So you would stand on top of a pen and draw a tangent? Or would you get on a gigantic pen like the size of the Empire State Building and turn it sideways?
You don't get it. All right, so look at. So this picture you can see, I don't know if you can see the flat Earth map here. This is called the North Pole. Somebody stands here in the center, right? And I said, if you're there.
Globe projection you got there. Like, that's the other thing, dude. You're upset over a globe projection.
I'm not upset about anything.
Oh, my phone died. Shit. Bye, guys.
Your phone died, but you're able to tell us that? All right. Let me just explain, because I was saying, if you're here at the North Pole, which way does the sun go? We know the sun goes this way. There's no question. We're not in Z-land where we say we don't know what the sun does. We know what the sun does every day. It's done it for thousands of years, and it will do it tomorrow and the day after. So it goes this direction. So if you're here, no matter if you're looking this way, or if you're looking this way, or if you're looking this way, or this way, on this map, the sun goes left to right. Left to right. This guy, left to right. This guy, left. He's like, what if you turned around? It's the opposite direction. No, it's not. If you're here and you turn around, it's still left to right. Turn around here, it's left to right. Okay? So on a flat Earth, the sun goes left to right if you're inside that circle. Now, if you go to the south here and you see the sun going the opposite way, the sun is now moving this way. And it doesn't do it once, it does it for 4 months. And again, what people didn't understand about this is we were showing this, people might think it just happens here. It doesn't matter if you're here, if you're here, if you're here, or here. Or if you're here, wherever you're at in Antarctica, the sun goes around you every day. Now, granted, if you're closer to the edge, it only does it on the solstice, and then if you closer to the middle, you get it for longer. But all these places have the sun doing this. So that makes no sense, right? Well, here's why it does make sense if you start thinking about it. Is because we know that the sun travels on the Tropic of Capricorn during December. Tropic of Capricorn is like right about further than that, maybe here. Make a different color, make it green. Okay, there's your Tropic of Capricorn. About there, okay? So here's the problem. We know that the sun travels above the Tropic of Capricorn December 21st. So the question becomes, when we went down, all I wanted to see, what I was looking for, they said, okay, one of two things is going to happen here. Either the people here are going to see the sun, sorry, let me draw here. So as the sun goes around here, let's say that we're out here, Punta Arenas, or we're out at Union Glacier. Either the sun's going to come around here and keep going this way because it has to get over to Australia. We know that it's on that path, on the Tropic of Capricorn. So it's either going to do that, but then when it's going like this around me, well, here's the thing. If it's doing this around me in Antarctica, I know that it's above the Tropic of Capricorn. Do you get it yet? How could this be the Tropic of Capricorn and this be the Tropic of... We have two Tropic of Capricorns? No, we have one. So when we realized that the sun came here in the north and then said, I'm going to follow you bitches down south in your plane, and then we landed and it said, now I'm just going to go around you for 4 days. Well, you should be able to put it together. That, oh, if it does that, it's because the Tropic of Capricorn is around this spot and it goes this way and comes back up here. How would that happen on a flat map? How am I seeing the sun here at midnight when it's over here? How would that be? So you can say it's a reflection. We can't see these stars, but we can see this sun. That makes a lot of sense. It's projecting 180 degree refraction. That we make fun of the globers for having 5 degree refraction. We're going to use 180 degrees. It's going to come all the way over here, be seen over here to my south. Or is it just the reason I'm seeing the sun here in my south is because it's above the Tropic of Capricorn here? And that means Australia is here. And then you're like, well, how could that happen? Oh, wait. There's a model that explains that to a T. So we can pretend it doesn't. You guys can cry like little bitches all you want. Or you can be adults and be like, oh, we should look into this. Because this map is no longer tenable at all. 0. And if you want to start invoking, oh, well, there's 6 different holes here, and they're portals that reverse. Somehow the sun's doing this, but it shows the sun go this way, and this sun has the same sunspots as this sun, except for they're upside down. And it also is seen to be a physical item. We can zoom in on it and see it's physical. But we'll call it apparent because Z wants to call it apparent, and a couple other flat earthers have decided that the sun's apparent, so we don't know where it is now. Or do we recognize that we know where the sun is? So people all ask me, they said, you keep saying we know what the sun does, but then you're saying you don't know. So yeah, we know it stays above this tropic. The question is this the tropic, or is the tropic down there around the bottom of a globe? That's your question. Now, since we can't explain it on this map, to me it goes, oh, this map can't be right anymore. You can say, oh, yes, it can. Okay, then show us. That's the great thing. I'm not saying anything's been proven. If I say that, then I close my mind. You guys have already decided things have been proven. I have not. I'm open to evidence. The problem is we don't have flat earthers anymore building evidence. We have people like Alonso lying, taking globe models, using the radius of the earth, using the Haversine formula, which comes from the globe, and then putting it on a flat map and calling it, let me bring up his site if I can find it. Gosh, what is it? Geocentric something?